Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis. Today we're going to be talking about ECAD. So when I was doing that laser project and stuff like that, there was a circuit board in there, and actually one of my friends, Edwin, made that for me. And somebody in the comments said, hey, it'd be really cool to learn more about ECAD. And I was like, you know what? I know nothing about ECAD, and I think this is a great way to see what Fusion can do now that it has ECAD built into it. So I picked a cool project. I actually bought this. It's a Velleman kit that you can buy, MK107. I soldered it all together. It actually works, so yes, I can solder, but that's about the extent of electronics that I know about. And this actually comes with a schematic and all this kind of stuff. You can kind of see it there. So we're going to use this in today's project. Now, I am not an electrical engineer, so disclaimer, I might mess up, I might do something wrong. You might be going, well, why didn't you connect that to ground or whatever? This is more to show how we have ECAD inside of Fusion and the power of being able to make changes. And I did get some help from my friends Edwin and Jorge, and they are on the chat today. So if you have any ECAD type questions, they'll answer them. I won't be able to. But my first impression of playing around with this in Fusion is I am really impressed. It is really actually kind of fun to do this project. I've included my outline in the description of the video here, so you'll be able to go through. I've included the schematic in there and stuff like that. With that said, please do not build it per how I've done it, because there might be something wrong. I personally recommend buying the kit and soldering it together yourself, but give the ECAD a try. Maybe design something pretty simple, like with a 555 timer or something like that, and see what you can do with it. So let's dive right in. So this is what we're actually going to be creating today. This is the board, and this is basically the final product. And you'll notice it has the LEDs and the IC chips, and there's a 555 timer here. And if I flip over to the other side, you can actually see all of the copper routes. And this was all done inside of Fusion 360. So let's dive in. So I'm going to start by going to File, and then you'll see this New Electronics Design. So I'm going to go ahead and do that. You can kind of see it switches to a new tab. And one of the first things I'm going to do is I'm going to save this project. So I'm going to go ahead and hit save. I'm in my project I want to be in right now, and I might call this I'll call it the MK107, and hit save. Okay. Then you'll notice these icons in the top. So new schematic, reference to an existing schematic document, new PCB, and reference PCB. Well, we're going to start by doing a new schematic. And we now are in another tab, and this is where we actually get to lay out this physical schematic that you see here on this board here. And so we're going to be kind of doing the same thing that you see here. We're going to be dragging components and then connecting them together. So again, I am not going to show every single command or anything like that. If you want to learn more about ECAD, I highly recommend coming out to our channel out on YouTube. And Jorge and Edwin have been doing a lot of live streams recently. So if I click on this past live streams, you'll see, for example, getting started with Fusion 360 electronics, and then there's electronics design manager, and schematic spice simulation. There's a lot of stuff out here in regards to the ECAD. So definitely recommend you watch those live streams to learn a lot more about what this can do. Okay, so I did the new schematic. One of the things I learned, which is really helpful, is to turn on the grid. So down here in the bottom, there's this little grid icon. and I'm going to go ahead and turn it on, and you'll notice that it's set to every 0.1 inches. And this will really help kind of line things up and snap things and make your schematic look much nicer. So definitely recommend doing the grid. And then the next thing we're going to do is we're going to start adding some parts, and you'll notice the icon is right here. So I'm going to say add part. Okay, so you'll notice that we have a library of a whole bunch of different kinds of parts in here. So capacitors and diodes and fuses and ICs, etc. And we're going to go through, and sometimes there might be a library, sometimes there might not be a library, and you'll see us run into that and how we solve that. So the first thing I want to place is, let's just start simple. Let's do the 555 chip, okay? So I'm going to do a search for star 555 star or asterisk. And what that means is it's going to find anything that has the numbers 555 in it. So when I hit enter, you'll notice it basically filters out everything, and it finds 555 in a bunch of different things. So for example, this IC clock timing, then you'll notice right here LM555N. So because we used the asterisks, it was able to find it inside, this LM and this N also. Okay, so I'm going to go ahead and I'm just going to expand open. Let's just see what this 555 is. And you'll notice there's a lot of options in here. So you can kind of see, and I click on these and it gives me a different preview of what these look like. So either board mount or through mount. And in this case, I want to do a through mount. So I'm going to pick this LM555 DIP. Gives us a lot of information about it, who manufactures it, all that kind of stuff. And again, I'm not going to spend a lot of time talking about all this. I just kind of want to show you the integration into Fusion. So I'm going to pick my 555 chip, say OK, and we can see it right here kind of attached to our cursor. And I'm just going to go ahead and place that on my screen, and it drops the IC1. Okay, integrated circuit 1, it labels it the 555 DIP. We can see all of the pinouts on it and their labels. Okay. So the next thing I'm going to do is I kind of start big. I'm doing kind of the main things such as the 555 and then the other IC, which is a 4015. So I'm going to do the exact same thing, say add part. I'm going to go ahead and clear my search. Okay, so we get all of our libraries back again. And I want to do a search for asterisk 4015 asterisk, and it filters everything out. Now usually if you don't see anything in these windows, you kind of have to like expand these open. So now I've expanded it open, I see that, and then I have a couple options here. And again, I like picking on them, and I can see a preview. So this is a surface mount, and this is a through mount, which is exactly what I'm using. So I'm going to go ahead and pick that guy. Now you'll notice something interesting with this image. So it's actually split. So we're going to end up placing, believe it or not, 3 things. So you can see we've got A and B, and then we have the power, which we'll come back to later. So I'm going to go ahead and say OK. And you can see it gives me kind of like a little thumbnail, a little bit of a preview what this is going to look like. Well, in my schematic, I want those 4 prongs, or whatever you want to call them, facing down. So a neat trick, instead of having to hit rotate up here, is you can just right mouse click, and it's going to toggle through those rotate. So I'm just right mouse clicking until I get those 4 prongs kind of facing down. So let's just go ahead and place that there. And you'll notice it says, I can't really point to it, but right here it says IC2A. And then I might place this one over here. And that one it says IC2B. And again, notice the numbers on these pinouts. So this is actually split into 2. I'll go ahead and say OK. And like I mentioned before, we'll come back to the power a little bit later. But the neat tip there is to use the right mouse click to rotate your parts around as you're moving and placing them. It's a really cool shortcut. Okay, Next thing I might want to do is add in the resistors. So let me take a look at my schematic here. So pretty repetitive. We're just going to come in here and say add part. I'm going to clear my search. Now I'm going to actually scroll through here until I see the word resistors. And you'll notice I actually have a couple of them in here because I've added some in, and I'll again show you how to do that. But let's go ahead and I'm just going to expand open resistor. I'll expand open the RUS. And then again, I like to click on these and we can kind of see what they look like. Okay, so there's again some surface mount ones, metric, etc. I'm going to pick this axial 7.2 resistor. Kind of see what it's going to look like. I'll say OK. And then I'm going to right mouse click to rotate it vertically. So you can kind of see it's now rotated vertically. And I'm going to just place it maybe like right here for now. Okay. Now here is where the turning the grid on is going to be really useful, because you'll notice that it's snapping to this grid. And so I could come over, for example, every third grid line and place it. And now you'll notice it says R2, R3. I'm just going to keep doing this until we get 8 of these guys according to the schematic, 7 and 8. I'll say OK, and I've now placed these 8 resistors. There are cool commands such as you can create patterns and all that kind of stuff. So I could have placed one and done a pattern that totally works, but I just went ahead and clicked to show you how using the grid and the snap kind of speeds things up. Next thing I'm going to do is there's LEDs right underneath this, and let me show you the schematic really quick so you can kind of see what we're doing. So we just placed all of these resistors right here, and now we're going to come in and we're going to place all of these LEDs underneath it. So you know, I'm kind of breaking this down into the bigger parts of this design. Okay, so let's go ahead and do a add. I'll go ahead and close that. Now I don't see an LED in here, so I like to use this search function. So I'm going to do a search for LED, you know, asterisk, LED, asterisk. I hit enter, and man, a lot of them come up. There's a whole bunch of them in here. Okay. So I'm going to go under optoelectronic, and you'll see that there's LED chips. There's also LED radial. And if I click on these, you can kind of see, sure enough, that's the style. So if I go to chip, for example, it's going to look like that, which isn't the style that I want. So I'm going to pick LED radial, and these are red LEDs. So I'm going to go ahead and say OK. And you can see, I'll zoom up here a little bit. It gives me an image of what that looks like. And so I'm just going to go ahead and place these underneath these existing resistors, like so. I'll say OK. Now you'll notice there's a lot of text on here. In fact, if I click on any of these LEDs, it gives me the properties of the part, like what angle, what's the device, what library did it come from, all that kind of stuff. Well, I want to keep the D1 through D8, but I don't need to keep these LED things. So I'm going to click on that little crosshair right there, just hit the delete key on my keyboard, and that's going to allow me to just quickly remove the text. I don't really want those to clutter up my design in this case. Okay. Now, I'm going to jump around a little bit. What I would typically do is I would keep placing my components, but I'm going to connect these together because I know that they're connected in the schematic. I don't want to forget about it. And to connect them together, we're going to use this connect menu, and the command is called net. So I'm going to click on net, and I'm going to zoom up a little bit so you can kind of see what's going on. You'll notice as I get near an object, this little circle appears. So I'm going to click there, and you can see it's creating this net for me automatically. Now, obviously, we're going to just go straight down. So I'm just going to quickly click these guys so I don't forget them, because knowing me, I would forget. So I'm going to go ahead and do that. And we're going to come back to the net command, obviously, as we start connecting all of these other pins together. Okay, I want to add a couple more resistors. And again, I don't know how long it's going to take to do this thing. We might go a little long in here, but let's go resistor. We'll do the same one. I'll say okay. Now I want to place R9, R10, R11 in a vertical orientation. And again, I'm just kind of looking at the schematic that came with this project. And so R9 is over here to the left of this timer. R10 is right above it. R11 is over here somewhere. And again, I'm just kind of mocking up where they need to go. And then R12 is over here, but it's horizontal. So I'm going to just right mouse click, and that gives me the ability, to put the name on the top, put the value on the bottom, for example. And I'll just place that. Let's just go maybe right about here. I'll say okay. Okay, now you'll notice with these resistors, it gives them a name, but it's not giving a value. So I'm going to go ahead and click on this existing resistor, and you'll notice value is blank. And I can actually come in here and type anything I want. So I could do like a 3K3, for example. Hit enter, and you'll notice that it puts that value in here. So like on the capacitors, you could say 1 microfarad, or on the resistors, you could say 300K or 3,000 or whatever you want in this case. Now that would take quite some time to do it for each of these. So what's really cool is I can actually select all of these at once. I could even draw a selection box around them if I wanted to. So for example, I'll grab these two guys and I'll just do these two. So I've got them all selected. You can see them in this table right here. And then I can come in and type in a value, 3K3. And we see that now they all have the value of 3K3, and they're labeled that way on our schematic. I recommend saving often, so I'm going to hit the save icon, and I could call this schematic MK107. I can give it whatever name I want, but that way we've saved. Okay. Maybe the next thing on the schematic I want to do, let's just kind of go back to here. So basically we've done the LEDs, we've done all of these resistors you see here. The next thing I'm going to do are these switches. Then we'll do things like the diode, the capacitor, and these jumpers and stuff like that. So let me jump back in here. Let's do some switches. This will be kind of fun. So I'm going to say add part. Okay. So I'm going to fold this down, and here is a switch. So I'm going to expand this open, and I'm going to start clicking on these guys, and you'll notice that these are all like dip switches, and that's all the options I have. It doesn't have that push button switch like I want. Okay, so this is where we can add in extra libraries. So I'm going to click on Open Library Manager. Okay. And you can see it says in design, in use. This is what I currently have in my library. And then we have available. And notice there's a ton of libraries in here from different manufacturers. So you'll see, like, for example, Eagle PCB. You'll see Hental in here, or Haytal in there. So, Seed Fusion, a bunch of different kinds in here, okay? So what I'm going to do is I'm going to search in here. So let's do a search for switch. I'll hit enter, and we'll see anything that has to do with switches. So you can see Worth Electronics in here. Okay, so I'm going to look for this Haytal. I hope I'm pronouncing that correctly. They have these frequently used switches. So I'm going to start with them. I'm going to go ahead and click on that and say use. Now you'll notice I've already used it. I can also, if I haven't used it, it'll let me download it and then I'll say use, but watch what happens now. Did I do that correctly? So I'll say in use, close this guy. So now you'll see that I have two switches in here. Here's that HeyTal library. So I'm going to expand that guy open, and here we can see a bunch of different switches. Okay. Now in this case, I'm going to pick on this guy right here. So you can see it's a tactile switch, which is pretty much the exact switch you see right there. Hopefully you can focus and stuff like that. So it's a little tactile switch. It's got the 4 prongs that go through the board. So that's what we're going to be using. So I'll go ahead and say OK. Here is my switch icon. And I'm just going to go ahead and place those above the IC chip right here. And I might rotate them to be, I'll just leave it like that. Let's go like that. I'll put one there, and maybe I'll bring one over here somewhere. Okay. Now, I'd like to keep those in line. I clicked a little bit too quick. So on any object, you'll see this little plus right there. So I can go ahead and let me zoom out just a little bit so we can kind of see what's going on. I'm just going to drag that guy down 1 notch, and now they're lined up real well. Okay. So next thing I'll do is I'll add in the capacitor. So again, using that add, I'll do a search because the capacitor is a 10 nanofarad. So I'm going to say 10 NF. Okay. And I hit return, and notice it found under SparkFun capacitors this 10 NF. I'll expand those open. That looks like a surface mount. This looks like a through mount. So this is what I want in this case. So I'm going to go ahead and select that guy. We can see the value right there. Say OK. And let's place this guy underneath our 555 timer, kind of over here to the left a little bit, maybe something like that. I'll say OK. And again, I'm just adding all of these different components. So there's a couple more capacitors. So let's go back into here. I'll clear my search. Let's expand open capacitor. I already had that library. It's part of the default library. I'm just going to expand open a couple of these and start clicking on them, and you can see the different options that we have. So I want to do maybe like a radial, like this guy, where it's a surface mount, a through mount, small diameter. So let's go ahead and pick that. And again, according to my schematic, this guy is actually going to be lined up with these resistors. So I'm going to do something like that and place this other one just to the left of it, like so. So there's my 3 capacitors. And actually, I'm going to move that guy over and move C3 over here, because C3 needs to be underneath those resistors. Okay, moving along. Next thing I want to do is the diode and then the potentiometer. So the diode, I'll do a search for that because it's a very specific diode called out on the schematic. So it's a 1N4148. So again, I'm going to do the asterisk, 1N4148 asterisk. And it returned a couple different options here from different libraries. Let's expand open this guy, and so you can kind of see that the 2 different images there. I'm going to use this mount, so let's go ahead and say OK. And that diode, I'm going to put way up in the upper left corner up here for now. Say OK. Let's do the potentiometer, so I'll click on Add Part again. And let's just do I could do a search for it, but I'm going to clear it so I get this. That way I can always scroll through and see, I've got pot, etc. So let's do that guy. Now, a lot of these so yeah, this is the Eagle PCB. So you'll notice that some of these are like the big mount ones, like so. We've also got some trim pots and stuff. I'm going to expand open this trim EU, and these are kind of more like what I want to be using. They're kind of those surface mount trim pots. So actually I clicked on the one I want to use, this guy here. So again, if I were to go through, you can see all the different options for these. Okay. So I'm going to pick on this guy here because it closely resembles the one that's on the board. I'll say open, and I'm going to put it above resistor 10. So let's just put it up here. And again, I kind of want to make sure it's sort of lined up. I don't want it to be off to the side a little bit. I want to keep my schematic as clean as possible. So I'm going to go ahead and place that like so. There's my pot. And then let's do a power in. So we need to somehow do the power, okay? And what do I mean by that? Let me show you on the board right here. So you'll see there's a 9-volt battery, and they actually, it's mounted to the back, right? And then it comes right into the board. So you can see it says black and red, okay? So I need to kind of simulate how that's going to work. So let's go ahead and add in, we'll just use a jumper in this case. Okay, so I'll fold this up and let's go to connectors. We want to do some kind of a connector. So you can kind of see here, I'll expand open connector and we can see all of these different pin headers. And this will basically allow us to, connect to something on the board. Now, I could do a through hole. I could actually do a jumper onto this. So I'm just going to go ahead and do the 1x2. So I'll go ahead and say OK. Oops, sorry, no valid. So I hit OK and it said no valid assets have been selected. Well, so that means I need to expand that guy open, and we'll see that there's two options, a vertical and a 90-degree. And this is, I think, the fun part of building these schematics, is just seeing all the stuff that's in here. I'm going to do the vertical one, and let's just place it, and I'm going to zoom up so I can see. I want those little prongs facing to the right, so I'm going to right mouse click to rotate. And so those little prongs are facing to the right. I'll go ahead and say OK. Okay, the last thing I need to do, and this will be, hopefully you can see this on the schematic, there is pin 16, and you'll notice it says VCC, so that's our voltage, and then we have pin 8 is going to the ground, basically. So you can pretty much see everything on the bottom is kind of our ground bus, and then everything on the top is kind of our voltage, like the positive run, okay? So I'm going to click on my existing IC. You'll notice it says 2A and 2B. Well, where's my power? I don't see pin number 16. I see 15, but I don't see pin number 16, and I don't see pin number 8. So I'm going to right mouse click on this, and there's a command in here called invoke. And when I click on invoke, you'll notice it's actually showing us gate A, gate B, and then we have this power gate. So I'm going to select that, and you'll notice that right now there's zeros next to it while the other ones have ones. So I'm going to say OK, and now you can see attached to my cursor is the power gate. So we got that guy, and I'm going to bring him over, and let's just put him somewhere maybe like in here. I'll say OK. And there you can see pin 8 and pin 16. So pin 16 is going to go to the positive line, and pin 8 is going to go to the ground line. Okay. We have all of our parts placed. I'm going to go ahead and save. I can give it a description. I'll go ahead and just say save right now. And this is going to be a little bit time consuming, so I don't know how much of this I'm going to do. We might have to do like a cake in the oven kind of a thing. But what I want to do now is connect everything with those nets, okay? And I might actually, I'm going to take these guys and move them down a little bit just to give me a little bit more room in here. So you'll notice I was able to draw like a selection window around everything, and then I can just grab and move those around. Okay, so I'm going to say net. And let's just start with this first resistor connects to pin number 5. So I'm just going to start at pin number 5. And I'll just come over like so. And it's kind of cool how it sort of like automatically routes for you. So again, I'm making sure I'm capturing that little circle. So pin number 4, so you can kind of see that little circle appear. Okay, it needs to come down. Now I want to make sure I don't click right on an existing line, otherwise it'll join to it. But I can go like something like that, and maybe something like so. That connects to the resistor 2. Pin number 3. So I'm trying to keep things as clean as possible. You know, I don't have to, but I think it's easier to read when you do that. So pin number 10 goes to resistor 4. So I'm going to come down like so. And here you can really see where the grid and the snapping really comes into play. Now, pin number 15 also connects to that. So I'm going to come over here, come down, and if I click on this line, you'll see that it actually puts that little icon right there. And so this is connected to that, just like it is on the schematic. Okay. Pin number 13. So again, I'll kind of try and keep things as clean as possible. So maybe I'll come over like this, come down like so, and click on that guy. Pin number 12. And again, I might be doing this not how a real electrician or schematic layout person would do it, so I apologize if people are yelling at me going, why are you doing it that way? But I'm just doing this kind of to show how you connect all these guys together. And then pin number 2 comes down like so, and there we go. And you know, maybe I could have rearranged these guys or something like that. I don't know, instead of having to cross over. I mean, that's up to you guys how you'd want to do that. So let's continue on. I'm going to draw a line from here kind of down and to the left. And this actually is going to go all the way over to our power. So I'm going to zoom out a little bit. Let's just go maybe to here. And we'll connect. You can see that little tiny icon appears that kind of snaps. So this is basically my ground. So I can connect all these guys, and you'll see how the little icon appears showing that those are all touching that line. Okay. So I'll keep going. Again, like I said, pretty repetitive, that kind of stuff. So let's see, this guy, this resistor connects, oops. So notice I didn't snap there, so I'm gonna hit escape. Make sure I get that little snap icon. I'll go to there. This guy goes up to one of the switches, so it needs to go up to this switch number 1. So I might come over here, something like this, and connect like that. And then the top is going to connect to another rail. We'll get to that here in just a second. This resistor 12 actually connects in right here. So I can do something like this. And then this guy connects with pin number 7. So I'm just going to come out here a little bit. I'll go ahead and click. Connects to pin number 7, but then pin number 7 also connects to the switch. Now the switch is kind of too far over, so I'm going to move that switch over just a little bit, which is pretty cool. And then I can connect from that point to that guy there. Okay. So we've kind of wired all that stuff. here, I'm going to come off of this switch. And little things I think makes it look cleaner is like, I'm trying to keep these things kind of lined up. I think it just makes it look a little bit nicer. So I'm going to drag this guy all the way over, like so, somewhere, and I'll just hit enter, okay? And it connects to my diode, so I'm just going to drag my diode up there, and it connects to the diode, and then my diode connects to the power. So let me zoom out a little bit. So again, I kind of want to line up with this guy here. Click and click. There we go. And that just looks kind of nice and clean, for example. This switch connects to this main line. Now, like I said, I had both Edwin and Jorge kind of help me out with this, and they gave me some tips and tricks. Like sometimes you'll want to connect these pins on these switches and stuff like that. I'm not going to in this particular case, but in reality you might need to or want to. I don't need to in this example. Okay, so the next thing I want to do is let's finish up with this 555 timer. So I'm going to maybe move him up a little bit, and we'll continue doing our routes. So C1 connects to pin number 5. So let's just go ahead and do that guy. Pin 1 connects to this bottom like so. Let's see, this guy goes to here, this guy goes to here, and resistor 10 goes to here. I'm just going to connect all these guys up because some of this references that. So pin number 2, which is the trigger, actually needs to go below this resistor. So I'll click that. Pin number 6 is the same way. It actually goes below the trigger. So I'm just going to do something like that. Okay. Pin number 7. I'm just going to come over here and, connects between those resistors. Pin number 4 actually connects to pin number 8, like so. And pin number 8 also connects to that guy. And so it's asking me, do I want to connect those segments? And I say, okay. Oops, maybe did I do that wrong? Give me just a second. Usually you see a ball, so let me try that again. Maybe I'll connect it this direction. No, maybe not. Okay, hopefully that's correct. Edwin or Jorge can correct me if I'm wrong there. Okay, so that looks good. So all of my 555 except for pin number 3, and pin number 3 connects with pin number 9. So I need to do my net. So here's pin number 9. And I'm just gonna do stuff like that. Okay, so then coming back to these guys, pin 14 connects to my resistor line. So basically this comes up and connects to that resistor. Pin number 1 connects to that also, connects to number 9. Okay. And then all that we have left is pin number 6, which, let me see, where is pin number 6 connects to that resistor line also. So I'm going to zoom out a little bit so I can see it. So pin number 6 needs to connect. I wouldn't say this is the cleanest looking way of doing it, but there you go. I'll say okay. Again, I could move some of these components around to kind of make things look a little bit nicer. The last thing I want to do is run this guy down and this guy up. Say okay. Okay. So that is pretty much it. I've connected everything with these nets. I'm going to save this guy. I'll say okay. Okay, now here's where the magic happens. So I'm going to say switch to PCB document. So I'm going to click on that switch to PCB document, and what you'll see is we're now in this schematic. You can see all of my components kind of grouped over here on the left. Okay, so there's my IC chip, there's my 555 timer, all the LEDs, etc. Now, I want this to fit on a particular sized board, okay? And I actually measured and I created a sketch of that board, and there's some holes that go through that board. So I want to, in fact, I'll just show you. I'll come over here. Let me open up my project. Here's that sketch. So I'm gonna go ahead and open that guy. And you can see here's the dimensions. I put these holes, they're 1/8" holes and stuff like that, okay? But if I go into create, you'll notice there's an option down here, create 3D PCB. So I'm gonna click on my profile. You see it kind of gives it some thickness. I'll say okay, okay. And then I can say, link to 2D PCB. Let me see, make sure I need to have saved that. Let me cancel. Let me go back to here. Sorry. I wanted to save this first, so I'm going to go ahead and hit save. That way I have something to link to. So now if I come over here and say link, there we go. I had forgotten to hit the save. So now you can see I can link to this. I'll select it and watch what happens. So now you'll notice that, you know, these are a little bit more larger, right? Because the board is smaller, and you can see the keep out holes. That's where the screws are going to mount to the 9-volt battery holder. Okay. Let me zoom up on this so you can kind of see what's going on. These little green lines you see right here are called air wires, okay? And they basically, when I move something, so if I were to, in fact, you can see they're already in the way. Let me try maybe this LED. So when I move that LED, you can see it's keeping those air wires connected. Now, as you saw, they get kind of in the way when I try and move some of these components. So one of the things I like to do is I don't want it to select, so you can see over here in this selection filter, I don't want it to select these air wires, so I'm going to control click on air wire, and now when I grab that IC, you can see it didn't grab any of those air wires. They still are displayed, but they're no longer selectable. So that's a neat little tip, is to uncheck that guy. Okay. So I'm going to move the IC kind of where I want it on the board. So I'm just going to drag it over here a little bit, like so. I'll grab the 555 timer. Now I want it to rotate. So again, as I'm dragging, I can right mouse click and it'll rotate for me automatically. So let's just place that maybe over here somewhere. And all it really is just dragging these components onto the screen, okay? So here's a cool tip. I thought this was so amazing. I'm going to position the LEDs so you can see that they're labeled diode 1, 2, 3, 4, 5. So I'm just going to kind of randomly, I want to make sure I place that where I want it. So let's say it goes right there. And then I can just drag these other guys near that, and who cares what the spacing is, honestly. Like, I'm just going to do something like this. 5, 6, 7, and 8. All that really matters is number 1 and number 8 in this case. You'll see some really powerful functionality here. So I'm going to put number 8 there. I'm going to make sure it's where it needs to be on the board. Let's say right about there, okay? Now I'm just going to select all of these guys. So I'm just going to draw a box around my LEDs. And under the place menu, there's this align command, okay? And there's a lot of options in here. In fact, if I had accidentally put these at a weird angle or something, or they weren't all lined up in one line, I could make them do that. But there's a really cool command in here that called distribute horizontally, and notice what it did. It repositioned all of those so they're exactly symmetrical with each other. They're lined up. Okay. Really cool command. And again, you can play around, like align top edges, align centers vertically. You can see all of the different options that you have on here. Okay. So I just positioned all those guys. Now, these air wires are kind of in the way. So another neat little tip is you can turn that layer off. So under layers, display, you'll see all of the different kinds of layers. And these air wires are what's called unrouted. They haven't been routed yet. So if I hit the eyeball next to that, you'll see that those turn off. And now I'm literally just looking at my components. And this, I think, will speed things up. So I'm going to continue placing my components. So for example, C2, yeah, I'm just going to drag him over here somewhere. C3 over here, but I want to rotate it so it goes vertical. And let's just put him maybe there. I'm going to move my 5.5 timer slightly. I know my switches need to go over here, and I'm going to rotate them so they're more rectangular vertical, like so. Oops, I'll go ahead and place that guy. Do the same thing with this one. I'm just right clicking as I'm dragging. So I'll go ahead and place that switch right there. Okay, let's put our jumper down here. This is kind of where the battery connects, like so. Here's our potentiometer. I'm just going to drag him and put him here. Okay, diode, and you can see that this is actually pretty fast. I need to make sure I grab the actual diode like so. He goes, I'm sorry, that's not the diode, that's the one of the capacitors. Let's put him there. This is the diode. I was looking at the wrong thing. Where does the diode go? He goes down in the lower right. So I'm going to put him down like so. Maybe even between these switches, or maybe like so. Let's maybe move these switches up a little bit, give us a little bit more room. Okay, something like that. Okay, now literally that's all that's left are all of these resistors. So I'm going to select all of them. I'm going to drag them a little bit closer. And a lot of these need to be vertical. So for example, I'm just going to draw a selection box around those resistors, start to drag them, and then right mouse click, and you can see how it's turned them to be vertical. Okay. Then I can come in and I'll just select one of these guys, resistor 1, and it needs to go there. Resistor 2 goes right there. You can kind of see what that looks like. Resistor 3 goes between those guys. So this, I mean, I think this is kind of cool. You're just basically building what you want the board to look like, where you want the components to be. I need resistor 5. Let's see. And resistor. Okay, so we did 5. Here's 6. So I'm going to rotate him and put them there. Resistor 7, rotate and put him there. I might drag these guys so they're a little bit easier to see, like so. Okay, and then finally, resistor 8 goes over here. Let's see, R8. Yep, he goes horizontally over here. And then resistor 9 and 10. Resistor 9 goes over here. And resistor 10 and 11. Oops, I'm going to start to drag and rotate. They go basically in here somewhere. So I'm just going to say like right there and right here. Okay. And then resistor 12 goes over here somewhere. So this is kind of the layout of the board. Again, maybe we're going to put a silk screen of a logo or something like that on there. I could keep messing around with this, keep tweaking with it, but I like what it looks like. I'm going to turn our unrouted back on so you can see all of those guys. I'm going to go ahead and save. Sometimes you'll get this, to synchronize, blah, blah, blah. I'm going to say, yes, I want to continue. Okay. Now here's where the cool thing happens. We want to start routing all of this kind of stuff. So under rules, DRC, okay, these are your design rules. You'll notice we can specify like what's the thickness of the layers, what's our wire clearances and signal clearances and all this kind of stuff, okay? From the sides, what's the size of our drill holes, what's the minimum width of our routes, and by default it says 6. I'm actually going to crank this up. I'm going to make it 12. I want it to be a little bit thicker. And the reason for that, let me switch to my camera, is you look at the back of the board, you can kind of see the routes and stuff like that. And I actually have this really cool ruler that I got, and it shows different thicknesses. I don't know if it's going to focus, but you can see, 10 mil, 20 mil, etc. and stuff like that. I can see different size holes. It's really kind of a neat little doodad to have. So I'm going to make this 12 mil thick. I'll say apply and close. Okay. I'll go back to my design tab, and here's the fun part. I think this kind of blows me away. We have this routing, and one of them is called auto router. So I'm going to say auto router. And I'm going to talk about this here in a little bit, but basically what it's going to do is it's going to try and route this the best that it can. Okay? So if I say continue and start, watch what happens. And it actually does it pretty quick, but see, here's the artificial intelligence happening. I mean, the fact that it routed all of those things automatically for me, literally in about 2 seconds, blows me away. Now I see an issue, and that is you'll see some blue lines and some red lines. Well, what's happening here is it's routing some of the traces on the bottom of the board and some of the traces on the top of the board. And in this example, there's no traces on the top of the board. So I'm going to cancel out. Let's route that again. I'm going to say auto router. And I don't want it to route on the top. And you can have multi-layered boards. That's what all this is showing here. So I'm going to change this from auto to not applicable. So the only one is on the bottom. Okay. Then you'll also notice it says effort is low, and you saw it only calculated like 4 tries. Well, you can do medium, you can do high, for example. I'll say continue. And now notice it's going to try a bunch of different ways of making this happen. So I'm going to hit start, and it's going to run. It's going to take a little bit longer doing it this way, but it's kind of fun to watch. This is my favorite part. This just blows me away because back in the day, you used to have to do this manually. You had to really know how to route these. Now you can still do it manually. And again, this is kind of an approximation, try and get as close as possible. And you might have to make some changes. What we're hoping for, I doubt I'll get it, is 100%. Okay. So it looks like we're going to hit 94% in this case. And I'll show you why here in just a second. So it's still running a couple routes. You'll also notice these vias. So having 0 vias is really good because that way you don't have to like jump or anything like that. So on the one that I did earlier, some of them said like 2 vias, some of them said 3 vias, etc. Okay, so it looks like we're getting close. But it looks like we're not going to hit 100%, of course. I was hoping to. So if I click on these, you'll see all of the different options that we have, okay? So I'm going to go ahead and pick this 94.2, and if I say end job, you'll see these little air wires, so it can't get from this pin to that pin there. So I might be able to maybe change the thicknesses of my wire. So let's go to the rules, DRC. I'll go sizes. Let's maybe make this a smaller distance. Let's put it back to 6. without getting into too much detail, this isn't creating radio frequencies or interferences or whatever, so the thicknesses really don't matter. In some designs, they do. But obviously in this one it doesn't. So I'm going to rip up all of my traces, rip up all the signals. Yep, so you see it kind of goes away. I'll do that quick route again. We'll do just the bottom layer. I'll drag this down. Hopefully maybe by changing the thicknesses, it'll allow it to route maybe a little bit better. We'll see. Who knows? If not, I'm going to keep going so we don't go too long, but I could maybe fix it by moving some of my components around. Maybe in this case, I would have to have a couple traces on the top of the board or something like that. So you can see we're hitting like 98%. So maybe just one component is causing us issues now or something like that. So let's just see what happens here. It's running all of the, and I just think this, I mean, it's fun to watch. It's almost like, I don't know, I hate to say artificial intelligence, but the fact that it's doing the work for us, pretty amazing, I think. Okay. So we got to, let's running one more. Looks like we're going to get to 98% is the best. There we go, which is this one here, right? So I'll go ahead and hit end job. And so it just, this one here, now to speed things up, I'm not going to worry about that. Obviously we do want to worry about it, but you can learn how to fix something like this in one of Edwin's or Jorge's live streams. So this is also another cool example. So these actually don't look too bad, honestly. Sometimes you'll get weird routes that kind of jump around a little bit. And this one turned out really good, honestly. But there's also under quick route, there's quick route smooth, and it lets you pick on your routes and they'll actually like smooth them out. Now, like I said, a lot of these are really, well, here's an example where it kind of zigzags down. Yeah, it actually is doing a great job. That's how powerful this thing is. So you can kind of see I can click on some of these and smooth out the run like that, for example. So kind of a neat little tip there. Okay, so let's just say this is what we want. We're good. I'm going to go ahead and save this guy. Okay, and then we're going to click on the View 3D PCB. And this is the way cool part. I just click on that icon. Here's my board. It's now going to populate that board with all of our components, like so. And there's our traces on the bottom. I mean, this just blows me away. I just think this is so wicked cool. Okay. So let's just do something like, maybe I want to move this diode or something like, or maybe let's just move the jumper. So I can actually come in here and in 3D, I could say move. And it's asking for the selection. I'll say that guy there. I'm going to look at the bottom real quick. Okay, so yeah, there's no traces in the way. So I'm going to move this guy. Let's just move him down and over. Now you'll notice the silk screen and the copper and all that kind of stuff are right there. But if I say update PCB and reroute, I'm going to say okay. Watch what this does. It'll actually figure out how to move these components and reroute the route. Okay, so it's thinking. Hopefully it'll do it real quick. Usually it's pretty fast. I'll let that think. Okay, I'll come back to that guy here in just a second. So that's about as much as I'm going to show. I'm going to come back to Fusion. I think it's auto-saving or whatever. But what we literally did is we took the schematic. Let me start with the schematic, okay? We mocked it up in Fusion, right? And connected everything with those nets. And then we positioned where we wanted those on the board and then pushed it to the 3D board. And we're able to generate this. And you'll notice there's actually the 9 volts screwed to the back, and so that's why I had those little holes right there for those screws to go through. So let me switch out of here. Oh, Fusion is not responding. That's fine. Well, anyways, you saw the 3D plate, you know, the finished product. I wanted to just kind of highlight how simple it is to you know, design a product, whether it's a vacuum cleaner, a leaf blower, a robotic arm or something like that, and the fact that you can create the PCB right inside of Fusion using the strength of Eagle. So yeah, here, we're back here. Using the strength of Eagle, there, it jumped across. Sorry. And if I rotate, you can see that the copper moved and the routes moved also. So the fact that you can even, you know, like I said, maybe we want to print something here, or maybe I want to put some kind of support in here and I need to move these components around, I have the flexibility to do that in Fusion. And I don't have to like send this to my electronic guy and wait for him to do something and then send it back, and we're exchanging different file formats. It's all inside of Fusion. So that's what I wanted to show. I appreciate Tyler on the keyboard. Jorge and Edwin, I think, were online also answering questions. I highly, highly, highly recommend you watch their live streams. They are a billion times smarter on stuff like this than I am. And there's so much power inside of the ECAD, inside of Fusion. So hopefully you found this interesting. Leave us comments, thumbs up, thumbs down, and I hope to see you on a future live stream. Thank you.